Okay. Functions involving E. The number E is another special number in mathematics like pi or I. The letter E was chosen to honor Leonhard Euler, pronounced Euler, who first discovered E and investigated its property in the 1700s.
Wow.
E is called natural base. So it's called natural base. Correct? For the exponential and log functions. So it's also called the natural base. Though you need to wait until you learn calculus to understand truly its nature. So what is it about? E is an irrational number. And its value is approximately equal to 2.71882828.
Yeah.
In the extension to this lesson, you can explore where this comes from. Okay, now let's simplify this expression. So E behaves like any other base. So what will you do within this one?
You'd add E, 9 plus 6.
9 plus 6 minus 2.
Minus 2, so it's 17.
Next one.
This you divide and then subtract by, so 5.
2, 12, 5, then
8 minus 3.
8 minus 3.
Which is 5.
5 e raised to
5.
Next. Minus 2 cube.
Yeah.
And e raised to minus 5x cube. What will this be?
So that would be minus 8.
E raised to minus 15x.
Yeah.
Use your calculator to evaluate. Correct? This is simple. You know where does E come in your calculator?
Yeah, it's this, right? You do control.
Correct.
No, it's just this, e to the x.
Yeah. So what's the value for the first one?
My calculator is e to the 6 is 403.
Yeah. 3 significant 403.
Yeah.
The next one?
This is easy.
3 significant figures you put it.
3.78.
Correct. Natural base function. The function of the form y is equal to a e raised to rx is called a natural base. Natural base, your e is the natural base exponential function. If your a is positive and r is positive, the function is an exponential growth. So if you're both a and r are positive, you will get an exponential growth. Exponential growth. Correct? If a is positive and r is negative, if a is positive and r is negative, you will get exponential decay.
What is r? Like what is it?
R is this number, the coefficient of x.
The coefficient, so it's like 2x.
2x, 3x. I mean, it's not called anything. It's just the in context of the thing which is given. State the domain and range and the intercepts of y is equal to a e r raised to x, an equation of any asymptotes. So we do the graph. I told you what does the graph look like. So in this case, what will the horizontal? This will have a horizontal asymptote. What's the horizontal asymptote over here?
X is equal to 0.
Y is equal to 0.
Sorry.
Correct. Domain.
Domain. All real numbers.
Yes, x belongs to all real numbers.
Yeah.
Range.
Range. Y has to be greater than 0.
Yeah. What's the horizontal asymptote? Actually, you know, this horizontal asymptote. This will go down like this. A is positive, no? So A is positive, how can it go down? That is, it is going like this. Okay, so horizontal asymptote?
X, Y is equal to 0.
Domain?
All real numbers.
Range?
Y has to be greater than 0.
Okay, so that's this part, right? This part. Graph the function and state the domain and range. At least 3 clear points should be shown.
Without a calculator.
Yeah, this is quite irritating without calculator, but without calculator you can't do this because e raised to powers hardly know the powers of a.
Yeah.
So you have to use a calculator.
Okay, so then it's easy.
Then you have to just enter some values, get some value, and do it basically.
Yeah.
Okay.
So just write the function and put find
Yeah. That is good.
Okay, yeah. Easy.
Easy, yeah. Then it's easy. You can't do it without calculator. The powers of a you won't.
Yeah, that's what I'm saying. It's
easy.
not that. Last lesson is more.
Yeah, it's just you have to use calculator. Then.
Yeah.
Annual sales of a product can be modeled by the function S is equal to 60,000 e raised to minus 0.15 t.
Yeah.
Where S is the number of units sold. So S is the number of units sold and T is the number of years since the product went in the market. Use calculator to model the graph. So you just have to, so what do we do?
So
type in your calculator. So do 60,000. 60,000 e raised to minus 0.15x. Graph it.
Oh, graph. At least in normal calculator.
Graph because the initial value is 60,000.
Yeah.
So what you need to do is your view window set boundaries. So your view window you can take your y minimum as you can leave it as let's say -2. Correct? Y maximum you make it let's say 61,000. Because maximum is 60,000.
And leave x min.
Leave as it is. So you'll see a graph like this.
Yeah, now I see it.
So it's very important that you see a proper view window. Because your initial value is 60,000.
Yeah.
So your graph is coming, your time can't be negative. So it will go from 60,000 and you don't have time negative. So this is your time and this is your S. And this is your 60K, 60,000. Correct?
Yeah.
So it's very important. It's a decreasing function because the power of E is negative.
Yeah.
Find the annual sales after the product went to market. 3 years after the product went to market.
So y is equal to 3.
X is equal to 3, no? T is the time.
Oh, yeah, it says T is the number. Yeah.
Use your calculator and get the answer.
Okay.
Correct? How long does it take for the annual sales to fall to half the initial value? What is the initial value?
Would it be
60,000, no? When T is equal to 0, 60,000
yeah.
Initial value is value when time is 0.
Yeah.
So this is always the initial value in your exponential functions.
Yeah.
Obviously, when your time is 0, anything is to 0 is 1. No?
Oh, right, yeah. So it'd be 60,000 times 1, basically.
60,000 times 1, the initial value. I mean, if you substitute that. What is the half of that value?
30,000.
30,000. So what will you do? You put S is 30,000.
Yeah.
Is equal to 60,000, correct? E raised to minus 1.5 times T.
And use your calculator?
Use your calculator. Solve any also you can do.
Solve right. Okay. I forgot how to do solve actually.
Or else you do what, from the graph, when your Y is 30,000, find out your X.
Yeah, that's what I was thinking. Yeah.
You can do that.
Okay.
You know how to do that on your calculator.
Yeah, you do tab and you put X is equal to 30.
Correct. X is equal to 30. Y is equal to 30.
So yeah, Y is equal to 30.
You'll get the X one. Write the formula for compound interest where I is the interest compounded n times per year. You know the formula?
I don't know.
A is equal to P 1 plus
R n
R upon 100n
R upon 100
raised to nt.
Yeah.
So n is the number of times it's compounded. So if it's half yearly, what will n be?
It's 4.
2.
Sorry, half. Yeah.
Half means you're getting twice the interest. You get twice.
Yeah.
If it's quarterly, what's your n?
4.
If it's monthly,
12.
correct? N is 12. You following that? So this is what you need to do.
Yeah.
If it's yearly, then what is it? N?
Wait, 1.
Well, obviously.
Yeah.
So why are you thinking so much? Continuous compounding. So today most banks use continuous compounding, which results in n approaching infinity. Continuous compounding. Every second your money compounds.
Yeah.
When the interest is compounded continuously, A in an account after T years, this is the formula given. A is equal to port.
Yeah. So
A
when
is
it
equal to P into E raised to R.
this is for when it's continuously compounding.
Compound.
Okay.
You deposit $3,000 in the account, which pays 3.5% annual interest. What is the balance after 10 years if it's compounded monthly?
Okay, so you use the original formula.
Use the
A
original.
is equal to P.
So A is equal to P. What is P? 3,000.
3,000.
1 plus
R is
3.5 upon 100. Or you know what you can do is, if you don't put this 100 now, you may not put this 100. Then you should put your rate as 0.035.
Yeah.
Because it's percent na?
Yeah, that's what I was saying.
So that's what some teachers do.
Yeah.
And divided by monthly means what will you take your NS?
So
12.
12, yeah.
And 12T.
12T.
12 into 10. This is your time.
And
so your for monthly
right,
N is 12.
T is per time, yeah. Okay, nice.
Then you put in a calculator and get
Yeah.
the answer. Continuously, what will you do?
So this would be A is equal to 30,000, 3,000.
E raised to
raised at 12.
how 12? A rate.
Oh, sorry. I was looking. E raised to.
This is the rate.
Yeah.
Where 12 came from?
I don't know what I was thinking. I was
okay,
thinking
and time is 10.
Times 10, yeah.
Use your calculator. Leave it. I mean, you know how to do it.
Yeah, I get it.
The base E is also frequently used the base for logarithms, and in fact is the second base besides 10 built in your calculator function. And it's given by ln, natural log. Natural log, and is written in form of ln. Can you see ln in your calculator? All the properties of logs apply.
ln. Yeah, right here.
Correct. So all the properties of logs apply. What does it mean? Then ln A plus ln B will be what?
Is it the same? Wait, the log is.
So ln A times B. So ln AB.
Yeah.
ln A minus ln B is what?
ln A upon B.
ln A upon B. Third, ln A raised to M will be what?
M ln A.
Okay. Fourth, what is ln E be?
ln E.
1.
1.
Because ln is log E base E is 1.
Oh, but what? You didn't write the two E's though.
But that's what. If you write ln, you don't put an E.
It would look like this.
So when you put E, it's the same as this.
Okay.
So please understand that.
Okay, alright.
So nobody is going to write it. So ln 1.
ln1 would be 1.
0. Well, log 1 to any base is 0. Don't forget.
Yeah, I remembered it was 0.
You follow?
Yeah.
Next, e raised to ln x
is x.
because your base is that is also e.
Yeah.
So the same rules apply, but it's written in form of ln. Your brain won't make that connection.
Yeah. But this was smart of you to write this. Now it makes sense. Actually.
Yeah. So this is what you need to remember.
Okay.
Please remember this.
Will do.
Next, now this is a calculator. Find out ln of
37. So just use my calculator.
Calculator and find out ln of the 0. Yeah, that we are now using, right? Express log 330 to the base 5 using natural logs. And the change of base formula, and then value to the nearest 100. That you have to use calculator. So what will it be? So log 330 to the base 5.
Yeah.
So that's ln 330 upon ln 5.
Why ln 5? Oh, because you also make
log 330 to the base 5. If we change the base, so let's log 330 upon log 5.
Oh, right.
And I am taking base e, but that's called ln. Now we can find out the value.
Yeah.
So ln
330
upon ln 5. So 3.6 nearest 100. So 3.60.
3.60, yeah.
Next, without calculator. Come on.
Simplify without a calculator. Without. INE.
LNE.
LNE. So make this into log.
1.
1. Oh, right.
Just
yeah.
now we did.
Right. Yeah, same rules.
Acha, this one.
IN.
Arey, ln it is. It's not
Sorry, ln 1 upon.
ln e raised to minus 4.
Yeah.
So that's minus 4 ln e.
Right. Okay.
Acha, next one.
3e ln 5.
What is
Would you pick the 5?
15.
15, yeah.
You remember that e raised to ln
Yeah.
x is x basically.
Right, yeah.
Next. Next, what will you do? E raised to ln
ln
2 raised to x.
Yeah.
So what will that be? 2 raised to x.
2 raised to x, yeah.
Because your e raised to ln x.
It cancels.
The basis, but this x has to be taken on top now because this is sort of be pure ln.
Yeah.
This and this should, if this e, this should be ln. No? This should not be e.
Yeah.
Okay. Expand. Expand.
Would you do 4 times 5x? So 20x?
ln 5 raised to 4 minus ln y square.
Yeah. So then now you
ln 5 plus ln x raised to 4 minus ln y square.
Yeah.
That is ln 5 plus 4 ln x minus 2 ln y. How can you multiply 5 by 4? You can't know.
I didn't understand what it means by expand. But basically you just use this
Rules of logs, no? We are applying the rules that I gave you, you just apply that. These rules that I wrote here, I'm just applying these rules, no?
Yeah.
Your plus becomes multiplication, no? And your also multiplication will become plus.
Yeah.
Your division will become minus of the ln.
Yeah.
And the power will come here. Next, combine this into single log.
So you're subtracting, so you're dividing. So IN.
It's ln x, not in.
Sorry.
ln x raised to half.
Yeah.
Get it
minus ln y
plus
ln z to the power 3.
Very good. ln
x
root x
upon y times 2 to the power 3. Yeah.
That's it. That's not 2.